Hi everyone, I'm Ramani Mirva, working as Solutions Architect at Open Source DB. Today, I will walk you through how to use DBtune for PostgreSQL performance tuning. We will cover the requirements to connect the DBtune, how to get it tuned, and how it how to get it tuning running, and finally, I'll show you the output and the results. So this is the DBtune page. Once we have logged in, you can go through the self-managed instance and PostgreSQL. I've chosen to not know to restart the database instance, and I have downloaded the DBtune client here and run untard the client on the Linux terminal. It's a DBtune supports all the Linux distributions, PostgreSQL database from 12 to 16 versions, and it all the PostgreSQL database to be tuned should have super user permissions, and these are all the prerequisites to keep in mind. Along with that, we need to have some installations to be done, such as some dependencies like we have Python 3.8 or latest versions, the pip, and also PSUTL PsychoPG2. These are all the dependencies to be pre-installed before the tuning sessions get enabled. Along with that, we need to enable PG underscore stat underscore statements for the database to make which helps DBtune to go through the logs and understand the how database response works with the different workloads. So I have entered this DBtune client, and in this you can see the YAML file where I have provided my database connection string here, and now I'll just simply start the tuning session. Just enable the DBtune client here. Once the DBtune client is enabled here, we'll go through the web page, UI page, and start the tuning session here. Then only the tuning session gets initiated. Yes. And you can see the tuning session got enabled here. Yeah, this is the dashboard where you can monitor all the uh, performance metrics, such as what are the parameters getting tuned and what are the tuned values, and in the whole tuning session, and what is the database, what is the query runtime, throughput, RAM. As we know, once the database is connected with the uh, DBtune, it will start analyzing the database. It checks the key metrics like memory usage, I/O performance, and query efficiency, and understands to also understands the database performance, how it works with different workloads. DBtune also looks at the current parameter settings such as shared buffers, work memory, and max underscore parallel workers to access if they are aligned with the workload. And based on that, it will start the tuning. So I'll just give some workload to this database. Get started. If this is reflected here, we can use any of the workloads. I'm just using simply PG bench. So you can see the database is start has started. Division has started analyzing the database. After this initial analysis, you can see first one more thing I have missed, that is Division takes total of 30 iterations to analyze the database and gives other output to give the best performance. Okay, so each iteration takes us around 7 minutes of time. So in these 7 minutes, it will go ahead and tune these parameters. These are the parameters which division is focusing on for performance tuning. So it will go ahead and mix and match the parameters based on the workloads. After the initial analysis, DBtune provides tuning recommendations. Maybe we can use those tuning recommendations, or we can manually tune the parameters as per our need. So for now, it is showing 5 MB. Okay. If the workload goes up or down, based on that, it will adjust the parameters. So this tuning session is still happening. I'll just take you to the through the tuning session which has completed all the 30 iterations. Okay, so this is the previous tuning session which I have used for. In this, I have completed 30 iterations. You can see the 30 iterations got completed here. 30 iterations output, and that these 30 iteration output, I mean the parameters tuned with different iteration, like 30 times. We can check out here. You can see download all. You can go through this CSV file in which you can see all the 30 iteration results of these 13 parameters. In each iteration, it will manage the parameters to give the best optimization. This is how we can go through it. Not only here, we can also check with the logs on the Linux side. Also, we'll have a log file. You can just go through there and check it out. Along with that, you can see how DBtune uses its RAM, thus RAM IO. Uh, so how DBtune uses database resources to give the best output. CPU usage, IOPS, and disk. All these can be, you can monitor here, and we can also check with the throughput. You can see the performance of database have been improved to 42.33x. Here I have you have gone through the throughput. So this is how what we can see the result. That is, we got 3,614 transactions per second, and at that peak result, best result, we these are the this is how the parameters are working to give that best output. Like this, we can see all the parameters, how they are getting adjusted. So this is our current session happening, current tuning session running on. So once the tuning got initiated, you can see the changes in the parameters. But for now, we can't see any changes. Why? Because as I said, it will take 7 minutes to complete iteration. Up to now, for this time, meantime, we can see 762 transactions per second, and through a query runtime is 1.5 milliseconds. For now, before completing one iteration, this is the uh, output you can see, and you can monitor the iterations, 30 iterations listed here, and in the log files you can go through the parameters, what are tuned at each what are the values of different parameters at different iterations. So to summarize, DBtune automates the entire performance tuning process, from analyzing database workloads to applying the best possible configurations. It helps to achieve maximum performance with minimal manual effort. If you have any further questions, please reach out to us. Thank you.